to look at questions based on galvanic cell. So if you have studied the notes, you will actually know characteristics of the galvanic cell and how does the cell functions and the components of the galvanic cell. So let's look at this diagram. You can see that this diagram is not normal. It's not the one that you are used to. You know that in galvanic cell you must have two different beakers which have like electrodes in each of them, and when you look at this one, it looks like some bent cylinder or something like that. This is like a curved cylinder also. You don't have a salt bridge. It looks weird, but trust me, this is also a galvanic cell. It has all the components which you can find in galvanic cell. You can see here you have a voltmeter reading. Obviously, another way to see that the cell given is a voltaic cell is to see the voltmeter reading, but sometimes they don't put a voltmeter reading. They can put something like a light bulb, anything like that. This is just to show that we can have a current flowing here. Okay, so we have our electrode. As you can see, this is nickel, and then this is a silver electrode, and again here you are given the solution, electrolyte solution. This is an I2 plus, this is a Ag2 plus. So these are the ions present in this side of the solution and also in this side of the solution. And then this thing is the one that is going to act as a salt bridge. So that means the solution from this side should not mix with the solution from this side. So the ion present here is not the ion which will be present here. And you see they say porous plugged or porous plug soaked in potassium nitrate. So this is what this thing has, the component that this plug has. So it is going to act as a salt bridge. So before answering any of these questions in this diagram, before you can see that there's nothing much given on the statement. The statement just says the diagram presents a galvanic cell labeled A. That's it. There's nothing more said around with what is going on here. So before you start answering the questions, it's best to identify anode and cathode of this cell so that you can know or you can be able to write the overall cell equation, or you can even do, what is this? You can even do cell notation. Okay, so identify anode and cathode. So you can see that you are given everything here. They gave you the metals that are in use and the ions in the solution. So that means you can find this information using your potential table. So in your potential table, you know how to use your potential table. So you're going to write the potential cell reaction of the nickel, and you're going to write the potential cell reaction of the silver. So I'm going to write them here, and we'll also look at their standard potential voltage as well. So here are the reactions from the standard potential table, and I wrote them in order. And the table I used is table 1. So you will remember that in your formula sheet you have two tables, and I prefer to use table 1 because in table 1 the content on the right they are increasing in reducing ability. So that means what is this? Ag has a lower reducing ability compared to nickel. All right, so you can see here that the standard potential of the Ag, which is silver, is greater than the standard potential of the nickel. So here you can, from these two reactions, you can determine which one is for anode and which one is for cathode. So now let's start and write our reactions in terms of anode and cathode. So remember, the highest potential equation will remain as a reduction reaction. So remember, all the reactions written in the standard potential table are written in a reduction form. So that means the gaining of electrons. So the one that has the highest potential is going to be the reduction reaction. So remember, in a cell, galvanic cell, we have a reduction reaction in cathode. That means in cathode we're gaining electrons. So we can indicate that for cathode we have this reaction Ag plus E minus. So you are going to actually see here, I wrote them with two arrows, so in terms of a reversible reaction. Okay, so but when you actually choose to write the final reaction for either cathode or anode, you can actually take one arrow. So here for the cathode, it will have a arrow which goes to the right to show that this silver ion is being reduced to silver metal. So that is what you have. Okay, that is the cathode reaction. And then for anode, you can actually write this reaction and you can just reverse it. So that means nickel is losing some electrons. So you can actually write it in this way, and then you want to take one arrow to the right and you just write Ni2 plus 2E minus. So I know that maybe some people can actually prefer to just keep the one arrow here. Maybe they don't want to reverse it and they just write it in this way. The only trickiest part when you write your reaction in this way is when you have to write this overall reaction of these two. So as you can see, when you write overall reaction, you have to make sure that you write it properly, unless if you can remember to do that. But I think it's best to just reverse it and take the fact that you have nickel and it's going to lose some electrons to become nickel ion. So now that we identify our anode and cathode, we can actually just indicate it on our diagram. So that means this side of the cell will be anode, and then this side of the cell will be cathode. And you can also identify the direction of the electrons. So how are the electrons moving in this cell? So since in anode we lose electrons, that means the electrons will actually move in this direction, E minus, E minus. So they are moving from the nickel electrode to the silver electrode. So you can be asked something like that. So it's best to just get all this information before you start answering questions. So far you don't know what is going on with the questions. Okay, so now that you have identified anode, cathode, the direction of the electrons, we can actually do cell notation as one. So for cell notation, you can actually know that in cell notation you start with anode. Cell notation, so you start with anode and then it followed by cathode. So this is what you have. So you're going to have your nickel as solid, and you can actually have a change of phase, and then you have Ni2 plus, and then you have a salt bridge here. So let me write quartz here, and then you have a salt bridge, and then you're going to have Ag plus, and then you have change in phase, and you're going to have Ag, solid. Okay, I'm also going to write solid here. Okay, so you got your cell notation. And then now let's see, the last thing you can do, you can also get the net cell reaction, or net overall reaction between these two. So you have these two, and you can actually get the overall reaction. So let's try and get it. So obviously here you can see that the electrons for Ag is not balanced with the electrons of nickel, so we need to balance that. So that means I can rewrite these two reactions, and I can actually, let me just write them here, and maybe here at the top. So you have Ag plus E minus, and then you will get Ag. And then you can also, to balance here, it means you must just multiply everything by 2 so that you can have a balanced reaction. And then here you can have your nickel, and it's going to be Ni2 plus 2E minus. So you can see that when you do the overall reaction, these two can cancel, and then you will have your reaction as nickel plus 2Ag plus, and you will get Ni2 plus 2Ag. Okay, I hope it's visible, but yeah, that is the net reaction. So like I said, it is best to write the anode reaction in a reverse order from what you get in the cell potential, so that when you do the overall reaction, you can actually do it correctly. Because if you do it in this way, you will end up adding these two together, and they will be on the same side of the reaction, which is going to be wrong. Okay, so now that we have analyzed everything in this diagram, we got our cell notation, we got our anode and cathode, we managed to identify the movement of the direction of the electrons, and I think now I can start answering the questions. Okay, so as long as you're given the metals on the question, it's easy to identify everything. The challenge is when you are given one metal and the other metal is unknown, so that is where like things can get a bit tricky. So if you know the names of the electrodes on your cell, you just go to the cell potential table, get those reactions, see which one is for anode and which one is for cathode, and remember for the cathode, the cell potential should be higher than the other metal, so that you can have a reduction reaction. Okay, so let's look at some of the questions here. So the first question says, state 2 standard conditions under which this cell functions. So obviously, if you know the theory part of this topic, you can know that there are standard conditions under which the cell has to function. So in this case, already you know that there is a concentration of what? Of 1 mole cubic decimeter. Okay, so we know that our cell can function well when the concentration of this electrolyte is in 1 mole cubic decimeters. Okay, so it said 2 standard conditions, so that means we need another one. So obviously the other one is that the temperature here, temperature should be, or like you can just say temperature at 25 degrees. So these are the 2 standard conditions that you know. it's available on the theory part of this topic. So that means if you know that okay, the cell will function properly when we have a temperature of 25 degrees Celsius. Let me just write Celsius, because if I just write degrees only, this will actually indicate that I'm talking about angles, so we are not talking about angles. So temperature 25 degrees Celsius, concentration of 1 mole decimeter cube. So you get your 2 marks. Okay, let's go to the second question. Second question asks us that we need to write 2 functions of the porous plug. So obviously this cell is not a normal cell that you know for galvanic cell, but we can actually see that, or we can realize that here they are trying to tell us that we can write function of the salt bridge. So these 2 sides of this curved cylinder is connected, or it's already connected by the way, but we can actually assume that this is acting as a salt bridge. So if you know functions of the salt bridge from your theory, it will be easy for you to answer this. So there's nothing new here. Don't be scared. Don't try to see that maybe this is something different. So we can simply say the first function of the salt bridge is to ensure electrical neutrality. So to ensure to ensure electrical neutrality. Okay, so some of the stuff I'm writing here won't really be that visible, but because you are listening, you will see that this is the word I'm trying to write. So to ensure electrical neutrality. Okay, the second one is to separate the 2 electrodes. Not electrodes, I mean electrolytes. So to separate 2 electrolytes. So obviously I said that the electrolyte solution on this side and this side should not mix, especially the ions of the metals. Okay, so if here you have a solution that contains nickel ions, these nickel ions should not mix with the ions on the side of the solution. So that is why we normally have 2 different chambers for this cell, but in this case, since we use a different device, we can try to separate them using this feature here, or this component here. But obviously if you can reason as well, you can see that this thing is separating these 2 solutions over there. So that is the other function of the porous plug. So you might not find this maybe on my notes, but I think by obvious reasons this thing is separating the solution on this side and another solution on this side. Okay, so let's look at our third question. Which direction from nickel to silver, or from silver to nickel, do electrons flow in the external circuit? So I mean, like, you already answered this question by analyzing the diagram. We don't have to think again. So it's gonna be this one. So obviously here is from nickel to silver. Obviously you already got your answer. So you see, some of the answers you already answered them by analyzing the diagram. Okay, so let's move to the next question. Write down the balanced equation for the overall net reaction for this cell. Do I have to repeat again? Let me just take it from here and I can just simply write it. Obviously guys, you can see that you don't have to think anymore. It actually saves you time as well, so that you can just get your answers straight. So you're just copying from your analysis, and yeah, you got your answers. Okay, that is the overall net reaction for the cell. Obviously I got it from here because I already knew the potential reactions of these 2 metals. Okay, so we have this one. So this one, it's a bit of it involves a bit of calculations. So since you do chemistry, you must expect some of the calculations in this topic, and not only the calculations in which you need to find the E cell or whatever that equation that you use when you calculate E cell in the galvanic cell, but another stoichiometry related calculations. So, and this question is actually focusing on that. So they say if 4 moles of electrons flow to a cathode, what will be the decrease in mass of the anode B? So remember that when you have a reaction going on here, this guy, since it's losing electrons, it's going to decrease in mass, and then this guy here, since it's gaining electrons, it's gonna increase in mass. So obviously, looking at this reaction, when this ion accept electrons, it becomes a silver metal. So that means when electrons comes here, then this will actually start to be reduced to a metal, and then we will see the increase in mass on the right side of the electrode. But on the left side of the electrons, while this is losing electrons, so I will get more concentration of the nickel here, because like it's shedding ions each time it loses electrons, so the mass will end up decreasing. So this is the equation that wants us to identify the mass which was lost when 4 moles or 0.4 moles of electrons flow to the cathode. So let's see what we have. So in order for you to calculate this, you have your reaction where you have your cathode reaction in this way. So you can actually take the balanced reaction or not. No, let's just wait a bit maybe. So for the cathode, you have Ag plus E minus, and then you're gonna get Ag. And then for the anode, we need to know the decrease in mass of the anode. So we need to know the decrease in mass of the nickel. So you have your nickel, and then you have Ni2 plus 2E minus. Right, so let's see. We need to compare the number of moles of the electrons. So they're focusing on the electrons, not the ions. So we need to actually relate it in that way. So in the reaction 1, I'm just gonna say reaction 1 and reaction 2. So you can see that in anode you have 2 electrons, and in cathode you are getting 1 electrons. So we need to use that type of a ratio. So that means you have 1:2:2. Okay, that's what you have. So, and that means for anode you're gonna be having the 2 electrons, and then for cathode it's 1 reaction. So that's the ratio between electrons in anode and cathode, right? So now I need to use this to get number of moles for the anode. Yeah, I'm given the moles of cathode, so I need to find number of moles for anode. So I use this ratio. So that means I'm going to have the fact that I have 0.4:2, and no, I don't know here, so I actually have to put an X. So you put an X. So in order for you to identify that X, you just do cross multiplication, and you will see that you have, if I just go that side, I'll have X is equals to, okay, let me start this question over. What I did previously didn't really, yeah, okay, I don't know, but I'm going to put it in the number of moles so that it becomes easy. So you know that using the ratio of this electron on the cathode, you relate it with the number of moles of the electrons on the anode. So that means for anode you have 2, and then for cathode you have 1. So that's the ratio of this between these two electrons. So now if we say that using the number of moles, that means you'll have 2n is to 1, or I can just say n, right? So I need number of moles for anode. I know number of moles or for cathode. So what I'm going to do is that I'm going to divide both sides by 2 here, and then this and this will cancel, and then I will now have the fact that the ratio now will become n over 2. So as a result, that means the number of moles of the cathode, you're going to divide it by 2. So that means for n anode, I'm going to say n cathode is equals to 0.4 divide by 2, and this will give you 0.2 mole. Okay, so this is going to be the moles for electrons in anode, but we are not really trying to find the mass of the electrons or anything like that, but we need to find the mass of the metal. So we need to relate that reaction, we are the number of moles for electrons with the number of moles for the nickel. Okay, so already when you know that you found the number of moles for these electrons here is going to be the same as number of moles of the nickel. So you can now actually go ahead to calculate the mass which was lost. So okay, I'm just going to write it here so that since I don't have enough space. So for the mass lost, n is equals to m over big M. So obviously mass, this is the one that we're looking for, but we know number of moles of that metal, and you can find it from the periodic table obviously, and then the number of moles is the one you calculated here. So you will have that 0.2 is equals to the mass is the one you're looking for, and then the molar mass is 59. That's the molar mass of the nickel, right? So don't use the number of moles of the silver, because we are not looking at silver in this case. We need to know the mass lost on the nickel, right? So you just cross multiply these two, and it will give you that the mass is equals to 11.8 grams. So I will have 11.8 grams here. So that is the mass which was lost, or the decrease in mass in the anode side. Okay, so just to try and revise this question a bit. So this question, they gave you number of moles for electrons, not for the actual metal or silver. So in order for you to get the number of moles for nickel, you have to start by finding number of moles of the electrons on the nickel reaction. So this is stoichiometry. So if you understand stoichiometry, this is not going to be a problem. So you will write your reaction like this, or obviously you can just relate. So you, for every electron in the cathode, it's related to 2 electrons in the anode. So you'll have their ratios written in this way, and that means you will have 2 multiplied by n for number of moles, and you're gonna have n here because it's 1. And then since we are looking for number of moles for anode, we're gonna just divide both sides so that you can get your answer in this way. So obviously you know that this is the number of moles for anode, So you're gonna substitute the given information from the question and you divide that by 2 and you get your answer in mole. So this will be the mole for the electrons, but it's going to be the one you use to calculate the mass of the nickel. Okay, I hope this is better. So here's the last question, and they like to ask this question a lot, so you must pay attention to it. There's only way to answer this question, and it's not that difficult as well. So they say a second galvanic cell B is constructed using magnesium. Okay, they give you the cell notation of this. So that means if the cell is starting with magnesium as a solid, this means this is the side of the reaction which is anode. Okay, so they gave you cell notation. So this is going to be the anode side of the reaction, but they kept the cathode side as it is, cathode. Okay, and I'm not guessing. The only way to know that this is going to remain as cathode is the way they wrote the cell notation. So they just separated, they didn't do it in this way. Okay, and don't be surprised by them including magnesium nitrate here. It's still okay. It means that is the solution in the electrolyte, so you don't necessarily have to write all of it. So but I hope this makes sense. So the fact that they started with Mg as the start of the cell notation, it means this is going to be your anode, and this remains as it is, so it means it will also be cathode on the second galvanic cell. So okay, they want you to answer without using calculations. So they say without any calculations, determine which one of the two galvanic cells, A or B, will result in the highest initial potential difference when it is operational under standard condition. And then they want you to explain by referring to the relative strengths of reducing agents. Remember, reducing agents are the content here on the right side of the reaction. Reducing as an agent, reducing agent. I hope if you know redox reaction, you will know the meaning of reducing agent. So they want you to refer to their strengths, and remember, if you use the first table on your cell potential, you will actually see the strengths of this reducing agent. It decreases as you go down through the table, right? So that means if you go to your table and look for the position of the magnesium, you will see that it's towards the bottom. It has a negative 2.36 voltage, and it's higher than the nickel. The nickel in this case has the higher potential compared to magnesium. So let's see, how do you answer this question? So they want you to state which of those two cells, the one with nickel as a anode or the one with magnesium as cathode, will result in the highest initial potential difference. So that means to answer this question, like I said, you're just gonna choose. So B will have the highest standard initial potential difference, and that is your first answer, B. You get a mark to state that. Sometimes if you don't know the reason, you can just write your reasoning without really, okay, you can write your answer without just reasoning. So that means for these 4 marks, you will get 1 mark for just your answer, but the remaining 3 marks are for you to state the reason. So what is going to be your reason in this case? So the reason is that magnesium, right, that is our reducing agent. Remember, reducing agent are on the right side of the standard potential reactions. So magnesium is a stronger reducing agent than nickel. So you have to compare those two components. So magnesium is a stronger reducing agent than nickel. So I wrote the full word of magnesium, but you can just write it as Mg. It's still okay. So you will get a mark for stating that magnesium is stronger reducing agent compared to a nickel. You get a mark for that as well. And then that means magnesium will be oxidized to Mg2+. So obviously if we talk about anode, we will say that the metal is being oxidized to an ion. So you will actually end your statement by saying Mg will be oxidized to Mg2+. So you can see even the answer here doesn't need you to focus in too much reasoning about the cell potential, what is going on with the potential. It just wants you to talk about the relationship between the two metals in their reducing abilities, right? And by using your table you can easily know that. So this question, I will suggest that if you do most of the past papers, pay attention to, you'll see it's always one way of answering it. You just compare the two metals. It's either depending on their oxidation ability or reducing ability. It depends on the question, and you just write what will happen with that metal. So obviously Mg will be oxidized to Mg2+. You just have to focus on that. Don't think too much about how is the initial potential going to be higher. So just focus on the fact that those two metals, what are the relationship between them in terms of reducing ability or oxidation ability. Look at your potential table, and you'll get used to answering this question in this way, and you'll see it's not that bad. So we are done with our question, and I hope this will make you at least have an idea of how to answer questions in galvanic cell, especially if you know a theory. And also it is best to analyze the diagram before you start answering questions, because it will save you time. So if you know the two metals given on the cell, try to find those reactions in the potential table. Look at the one which has the highest potential, so it means that will be the reduction and it will go to cathode, and the one with the lowest potential will be the anode. In that way you will actually identify the direction of electrons. You will be able to write cell rotation. You'll be able to also write overall cell reaction. You can also be able to identify your reducing agent, your oxidation agent as well. So once you have a question which have all the information given, you must be happy, like, oh wow, this is going to be a straight sail or a smooth sail. Yeah, let me put it, a smooth sail. So you don't have to stress too much. You just answer questions before you actually read what you are given on your question paper as questions, so that it will also save you time and you won't have to think so hard. The only challenge is if you don't know the other metal, but also maybe if I get time, I'll do another question wherein you don't know the other metal and we can see how we work around it. Anyway, thank you for your time, and I'll catch you on the next one. Bye.